Taking a look at a new example, a bowling ball of mass big M and radius big R, whose moment of inertia about its center is 2/5 mr squared, rolls without slipping along a level surface at speed v. What is the maximum vertical height to which it can roll if it ascends an incline? All right, so we're asked for what final height it could reach if it starts with this initial speed v. And so essentially we're dealing with conservation of energy again. At the bottom of the ramp, the ball is moving translationally and it is rolling, so we'll have both types of kinetic energy. And then at the very top of the ramp, just like before we introduced rotational energy, all of that energy is going to be converted to our gravitational potential energy because the ball won't have any movement at all anymore. And so our initial energy, we'll say that's at the bottom of the ramp, equals our final total energy. And initially it has translational kinetic energy and rotational kinetic energy. And at the top of the ramp, all of that's going to be converted to gravitational potential. And so then we can put in, I'll just put in the general statements for energy. So 1/2 mv squared plus 1/2 I omega squared equals mgh. And now we can go ahead and put in the specifics for our problem. So we know m is capital M, mass of the ball, v squared plus 1/2. I, they tell us, is 2/5 mr squared, and then omega squared. But just so we have things in terms of the same translational velocity, we could go ahead and substitute in that v over r squared for omega squared. And then that equals big M GH. All right, so that is our equation. Let's go in and simplify. 1/2 big MV squared plus 1/5. And after we cancel out the r squareds, mv squared equals mgh. All right, so then it's just down to 1/2 plus 1/5 mv squared. And that's going to give us 7/10. Another thing I did, we could write in the m, 7/10 mv squared equals mgh. We could have done this at an earlier step as well. Notice how we do have capital M, the mass, in each of our terms. We can go ahead and cancel that out. And then we want to also go ahead and divide both sides by g to get that height by itself. So our final answer, that total height that it can go to with its initial energy being what it was, is 7v squared over 10g. And I just went ahead and combined that into one fraction. So that would be our max height in terms of that initial velocity.